Welcome once again. So we take an example from the previous lecture. Alright, so this is an example from the binomial distribution. Alright, so it reads like a fair coin is tossed 6 times. Find the probability of getting I exactly 2 hairs, I at least 2 hairs, I 2 tails, and Ivan at most or 2 hairs. Alright, so here from the given question we are tossing what a coin, and remember a coin has only 2 possible what outcomes, right? That means we either get a head or what the tail. So let's assume getting ahead is our success, right? Getting ahead is what our success. Remember this is 2 what events, right? So it's either we can get the head here or the tail. So let's assume the head is what the probability of a success, right? So getting ahead is a success. Probability of success for each trial will be P. For success, P will be equal to 1 over 2 for each trial. So immediately we have P as 1 over 2. We can easily get the Q as what? That is failure, as 1 minus what P, which is 1 over 2, and it's also 1 over 2. Okay, so we have this, that is the probability of success half, and then the probability of what failure is also half. Alright, so the number of trials is also very important here. That is our n. The number of trials is what 6, because we toss it 6 times. That is from the given question 6 times. So the number of trials is 6 here. Alright, so here we let x denote the number of what successes. The number of what successes. So let x denote the number, denote what the number of successes. Alright, so it means that for each what p of x, which is giving us this x, is giving us n combination x p to the power of x q to the power of n minus what x, has been explained here. Alright, so if we are to work for exactly 2 hairs, that means exactly 2 what success, exactly 2 what successes. If we have exactly 2 hairs, then our x must be 2. Our x here must be what 2. So we are going to get p of what x equals 2. Remember. Alright, so we have 6 combination 2, then p, and p is 1 over 2 half to the power of what 2, and then times q is also half to the power of 6 minus what 2. This is n, so we have 6 minus 2, and that is 4. Alright, so this will give us that probability. So if you use your calculator to simplify this further, we have to get this is 15, 6 combination 2, and then times, that is 1 over 4 here, times 1 over 2 to the power of 4, which is equal to 15 times this 1 over 64. Alright, 1 over 64. Then 15 times 1 over 64 is simply 15 over 64 as our given what probability. Alright, so we move on with the II. We are to find at least 2 hairs. At least what 2 hairs. Remember, at least means what 2 or more. So we will explain it as P of S greater than or equal to 2. That means at least 2. That means the probability of getting 2 or more what hairs. 2 or more what hairs. But remember, if we are to say that 2 or more hairs, it means that we have to work for probability of what getting 2 plus, or we can get the probability of what getting 3, or we can get the probability of what getting what 4, or probability of getting 5, or probability of what getting 6. Alright, so but we can see that working all these ones are too tedious. It is too tedious for us to get an answer for us. So whenever you hear of at least is simply what you can easily say that at least is 1 minus P of what x less than 2. Because if you have the probability of what getting at most 2, right, at most or 2, then you subtract it from 1, then you get what the probability of at least or 2, without going through all these what long process. Alright, so from here it means that the P of s greater than or equal to 2 here is going to give us 1 minus P of what s less than 2, and that is probability of getting x, which is nil, 0, plus probability of what s getting what 1. Alright, that is for that. Alright, so here we have 1 minus the probability of getting 0 is 6 combination 0, and then the success is half 1 over 2 to the power of 0, then times 1 over 2 to the power of what n minus, that's 6 minus 0, which is 6, right? And then plus the probability of what getting 1, that is 6 combination 1 over 2 times 1, and then 1 over 2 what to the power of what 5. Alright, so simplifying further, we are going to get 1 minus 7 over 64, which will give us 57 over 64. Okay. Alright, so for the third one, that is probability of what getting 2 tails. Probability of what 2 tails. Alright, so here, before we can get a 2 tail, remember that the probability of success is what P here, and that of failure is what Q, and Q represent what tails. So if we say 2 tails, that's what make the n minus x here to that power of here, this ought to be what 2. So we are going to get Q to the power of 2, and then P, which is to the power of this x, remember, is going to be 4, because we have n to be what 6, isn't it? And so 6 minus 4 is definitely 2. So if Q has a power of 2 here, definitely P is going to be a power of what 4, right? So we are going to get n combination, that is 6 combination 4 because of x here, and then 1 over 2 to the power of 4 times 1 over 2 to the power of what 2. That is it. Remember, here we are talking of a tail, so we just exchange, right? So you let this become what the success. It's like behaving as the success, right? So 2 tails, where you raise it to the power of 2, and then this one to the power of 4. Alright, and this is going to give you 15 over 64. Alright, So that is the probability. So let's move on to the last aspect, at most 2 hairs. So we have probability of at most 2 hairs. And this at most 2 hairs is defined as what? P of x less than or equal to what? 2. That means we have less than or equal to 2. Alright, so the probability of obtaining less than 2 or what? 2. So it means that we have to work for probability of getting 0 and then plus probability of s equal to 1 up to plus probability of what? X equal to what? 2. Alright, so we get this as the given values here. Alright, so 6 combination 0, 1 over 2 to the power 0, 1 over 2 times 6 plus 6 combination 1, 1 over 2 to the power of 1, 1 over 2 to the power of 5 plus this and that. Okay, so this one will end up giving us 11 over 32 as the given probability. Alright, so on this note, I would like to end this here, and thank you all for watching this video, and don't forget to subscribe to this channel. Alright, I'm called Osu Kwesi Frank, a student of KN University, third year mathematics student. Thank you for watching. Bye.